Today's project, so in the end, the map we're going to produce, there's no real point to this map. Like we're not performing analysis. It's not going to be overly beautiful. It's going to be kind of totally useless in the end. But I kind of chose a workflow just to show you a bunch of different tools. So like that's the ultimate goal of this, is just to show you where all the tools you're familiar with are in Q, and so there's going to be a lot of contrasting, like this is how we do it in Arc. This is what the button's called in Arc. How do we do it in Q? Where do you find that button? I'm going to be doing a whole bunch of that, and just covering the really general workflow. So like I was saying, like these are the goals for today. This is what I'm hoping to accomplish and show you guys. So yeah, just where the familiar functions are. Things you've already done in Arc, and then a difference between Arc and Q is that there's a whole bunch of plugins that you can just install for free from within the software, and we're going to use those to get some data. And then in the end, one of the most different things about Q is the print composer, and this is where a lot of people just look like deer in headlights once they get to this point. It's really different, and it's not obvious. It's not intuitive how to make a map with that. So. Here's the lesson plan. We're going to make our own text file with coordinates in it. We're going to turn that into a shapefile. So really, my goal today is we're starting from nothing. We have no shapefiles, no input layers, and we're going to wind up with a complete map at the end of it. Generate a study zone from that point. We're going to get some street network data from OpenStreetMap. Who's familiar with the OpenStreetMap project? So it's an open source project. Any of you who've done projects here before, you realize like how finding data can be a real big problem. And like here we're lucky we have files on the drives with the road networks and whatever. But once you graduate and you don't have access to this information anymore, finding this data is that's one of the biggest challenges. So the OpenStreetMap project, it's people from all over the world who are geocoding the streets themselves. Like they will record their own GPS points, go create the lines in the map, and then add it to this giant collection of all the streets in the world. So it's an online, we can access the data. We're going to use a plugin to go and fetch some of that data. We're going to get base maps from a plugin, and then for the print composer. So for starters, we're officially beginning now. So I hope everybody already has QGIS open. Make sure it's open right now, and then go and open Notepad. And we're going to make a text file that we're going to turn into a shape. So you can always just hit the Windows key on the bottom of the keyboard and then start typing note, and you'll see it will pop up. And now all I did was I Googled coordinates in Montreal. And now, what kind of coordinates are these? Who knows offhand what kind of coordinates these are?
Latitude and longitude?
Yeah. And so what kind of projection system is that in? It's this is a geographic. As soon as it's latitude and longitude with degrees and stuff, it's a geographic projection system. And here, like, it's telling you north and west, but north and west, when we load this file in, it's not going to make sense of N and W. So instead, we're going to put a negative sign here to indicate that we're on the west side of the meridian. So make this file, name it coords.txt or whatever you want, and also we're going to make a project folder. You can go into My Documents, you can do it on your desktop, whatever you want. This project is going to be too big for the P drive, so don't work in the P drive. And then at the end, either you're just going to delete your whole folder or copy it onto a USB key. If you don't have anything to copy it with, the instructions I'm going to give you, really, you'll be able to recreate this, especially once you go home. You'll be able to recreate it way faster. So if you can't save your data, don't worry. So for now, just, we need to make a project folder either in My Documents or the desktop or whatever. You can make this. Yeah, that's fine. And then just do save as, and make sure it's saved as .txt, and put it in whatever folder that's going to become our project folder. So it's got to be on the C drive somewhere. So you can, name it, coordinates, Montreal, and something, for your personal reference, something you can find easily later on. right? Everybody's got the numbers written down. I can go to the next slide.
Yeah.
Okay. So we're going to import this file and create geometry from it. So in Q, step 1, in the layer tab, we're going to add a layer, which is very similar to the add data button in Arc. Here it's called add layer. So, show me your, was that saved? Yeah, don't put the asterisk there. Also, general GIS, helpful convention is in your file names, in your file paths. Don't include spaces. Don't include funny characters like plus signs or dollar signs. The computer, it might hit a line of code where it interprets that like a math operator and then just throws an error. So don't get rid of that and call it, what is it? It's lat and then lon. No, what is it? Yeah, lat lon should be the. So this is like the header. This is the header of this file. So now, so add the limited text layer, and then you're going to get this window that pops up. And okay, it's actually not fitting on the screen. Oh wait, there's an auto size thing here. Okay, a bit better.
Sorry, when we save it? We save it to where?
In a folder that you're going to use for the rest of the class. So either like on the desktop, create a folder, call it Intro to Q, or in my documents, something like that. So on this window here, we're specifying that it's a comma separated values. We're specifying that we are feeding it a point coordinate, and then we're going to show it which columns to go and find those coordinates, the column headers. And then so then here, it's going to give you a display of how it's going to interpret it. So, of course, you have to go find the file that we're going to import. So you have to go back to that folder where you put it. I think so. Okay, now, if you're not getting the preview on the bottom, it's because you have to go and tell it where the coordinates are stored. Well, because here we're importing the geometry. So we're creating a file from scratch. Yeah. So when we give it the coordinates, it doesn't even know what we're trying to create yet. So we go in and we say, hey, I'm making a point. I'm creating a point. Now a point, to define it in space, all you need is an x coordinate and a y coordinate, and that's it. So it's totally normal that you see it all on one line there, because we're only adding one feature, and these are the only the attributes in the table. It's the only info that it has. So everybody's there. You've got it. You've got it. How are you?
It won't say the typos down.
No. Don't. If I didn't put a red box on it, don't click it.
But it doesn't allow me.
Well, I don't know what's going on in your.
Yeah, now it works. Never mind.
Yeah. So your latitude value should be 45.5. Okay, so everybody click next, or OK. Okay, so now this, like I said earlier, it doesn't know what we're trying to create. We're just throwing numbers at it. It doesn't know what we're trying to do here. Now on this screen, it's saying, okay, I recognize that you just gave me some coordinates, but what coordinate system is that in? It needs to know. It needs some sort of reference so it can situate these coordinates in space. So I said earlier, it's a geographic coordinate system, right? So in the list here, you should see it should already be highlighting the datum WGS 84. So we're saying, hey, it's a geographic. They are geographic coordinates that we're giving you, and they're based on the WGS 84 datum. So it's just going to help it situate it in space. And so once you select the WGS 84, you can hit OK. Okay. when it comes to, so right now it's in latitude and longitude, it's in a geographic coordinate system. We want to change it to a projected coordinate system so we can start working on it. This is just like a general good practice. We're going to convert it into units that are meters instead of decimal degrees. Now in ARC you might be used to going into the toolbox, finding the project tool or like reproject or all these things. It's not like that in Q. How you do it is, I just want to make sure everybody has this before I go to the next slide. On your layer, okay, cool, everybody's got that. So once you have your point layer in there, right click on it, go save as, and actually this is where you change your projection. So you open up the save, and this is the same as in ARC when you do right click data, export data to make a new file with like your selection or whatever. Like look, you could do save only selected features. This is the same functionality. So but this, so there's no like reproject tool. It's via this right click menu that you get this, and then you can open this drop down menu, choose what coordinate system you want, and when it saves the file, it's going to reproject it into that coordinate system. So everybody here, and you open up this menu here, and there should be like a type in search box at the top, and type in 32618. If you click the little globe,
Where? Sorry?
if you click this first, I mean you're gonna what the new file will be named, and I would suggest like MTL underscore UTM. We're gonna be converting it into a UTM coordinate system. Yeah, so in here, when in filter, I think up here, if you just type in 32618, 18. So you can name it like, sorry, no, not capital letters, that's really bad. Start MTL underscore UTM, and the CRS we want is 32618. And for the geography nerds in here, for the GIS nerds, make a side note, if you want to go deep into the CRS rabbit hole, start looking up EPSG codes, what's an SRID? What does SRID 32618 mean? What does that even mean? What does that do? And so SRID codes, EPSG codes, these are something, okay, so I didn't start by introducing myself, but I'm a master's student here, and I do transportation planning analysis, and my work is GIS beginning to end. That's all I do. I did both of the courses here. I got great marks on them. I've TA'd them. I got to my own personal project. This SRID thing, I had no clue what it was, and seriously, it wasted about 2 months of my time figuring this out. Now, also, when you go out into the industry, every GIS system you're going to use, everything you're doing, they revolve around these. So to me, like, this is a hole in our courses here that like you're not thoroughly exposed to this. So if you really want to do this moving forward, Google SRID, EPSG, yeah. Okay, so everybody, you have your 32618. Click off, tick off, add the file to the map.
I'm not sure.
Avoid capitals, avoid spaces, avoid fancy characters. Because if you don't, maybe like a tool 7 steps from now is going to start giving you a weird error, and it won't even tell you like, hey, your file has a space in it. It's just going to be some weird error that you're going to be Googling and chasing and trying to figure out, and it's only because one of your files is named wrong. So add the file to the map if you're good. If you have 32618 and everything.
Save error.
Yeah, yeah, do that. Always use the browse button. Use the browse button to show where you're going to put the file. Is that what you did? You used browse and went hold it in place? Yeah. Okay. So. Okay, so now in your layers, you have two point files, and can you see any difference between them? Okay, so how many people here have done the advanced GIS class? Must have, you guys have. Do you remember, this is a weird thing in ARC where when you open up a blank map, there's no coordinate system. It's empty space, it's nothing. And as soon as you drag a layer on, it changes your whole frame to be that same coordinate system, right? And then if you drag in a layer with a different coordinate system, you might get a message saying, hey, these things are not in the same coordinate system. Do you want me to transform it so that on this screen it actually coincides? Q does this automatically right off the bat. So right now, Q is juggling these two different coordinate systems and displaying them as one on your screen, which can be very misleading because it looks like everything coincides, and then you run a tool later on and you get no results because actually in space your things are like super far apart.
If you
but
zoom out, you could actually see them apart as well.
Yeah, if
you zoom out a little bit.
they're a little bit different. Okay. So right now, if you go up, this is another. This project properties window here is something you're going to use a lot in Q. And here's your CRS. And I would bet that everybody right now has this enable on-the-fly transformations.
How'd you get there?
This was just project and then project properties. Here, I'm just showing you that the box that says on-the-fly transformations, if you go into CRS of your project, enable on-the-fly transformation. So on your screen right now, it looks like the 2 points coincide in space. In the memory of the computer, in the actual coordinates of where they are stored, they do not coincide in space at all, and it's only showing you for like your reference, like maybe you just need to come in and check something, maybe you just need to print something, maybe you're not doing spatial analysis, whatever. So anyways, this is like a side tangent just to explain a bit of the functionality of Q and how it's different. So
it should be unchecked or checked?
Right now, we're going to make a brand new map file, and we're going to scrap the one that we just did because right now our screen is in the initial coordinate system, the WGS 84, the geographic one, and that's no good for our needs. So now the next step is to wait, where were we here? Start a new map. So in the top left corner, you'd have like the new button. So you can close your project properties. I just want to show you something. Yeah, and then just start a new map. Don't save the changes. And now you can go in your browser panel and find that file that we just made. Or like if it's on your desktop, you can drag that shapefile from your desktop and drop it into the middle of the map. Sorry, I didn't make a slide for this one, but so like here in the browser panel, yeah, the .shp of your Montreal UTM.
Would you get a message if this was unchecked here?
No.
Or does it still not give you a message?
No,
It always does
and
it?
like anytime you add in something different, it just automatically ticks that box, paints them coinciding, and you have no clue that your layers are not in the same thing. So that's where like an ARC is consistently more user-friendly than Q because it will give you this warning saying, do you want me to transform this? Here you don't, and that's another thing that like I wasted so much time on, like how come I'm not getting results, what's going on, fighting that checkbox, trying to understand what's going on. So now if you go back into project properties, you'll see that the coordinate system of this project is now UTM. It's the decimal degrees. Okay, so everybody's there. Everybody's got like their new point in their UTM map now.
So the only way to do that was to close it and then open it up again?
Yeah, because it's always, whenever you have a blank, like empty project, the very first layer you drop in dictates the coordinate system for the whole entire project the whole way through. And if you drag in different ones, all it does is display them like they're overlapping.
Right.
But in the memory of the computer, if you look at the actual coordinates, they're separate in space. So like now, like the first one we made, it was like 45 dot whatever minus 73. If we drop those in right now, a UTM grid, it's a box grid starting from 0 in the bottom corner. And if you put in your 45 and your 75, whatever, it's going to count 45 meters minus 75 meters. Okay, this is where your point is. But actually, Montreal is like somewhere up here. So anyways, that's like a total side tangent. All right, buffers. People are probably very familiar with this tool now, and this is one of the things where in Q, like you dig through the menus for like 20 minutes and you can't find it, and you're like, what the hell's going on? Like, this is one of the most normal GIS things. How come I can't find the button? What's going on? And the reason is that the button is called fixed distance buffer. So if you're scanning around looking for the word buffer, you're going to miss it because it's called fixed distance buffer.
Well, so on the versions that we have, it's going to be buffer. On the
Oh, yeah?
2.18, it's fixed distance buffer.
Oh,
So
cool.
it'll be the buffer.
All right.
2010 2.18.
Okay, so if you have, so you're going to click on, wow, this really isn't very sharp on this screen. So the top menu, you click vector, geoprocessing tools, and then it will either say buffers or fixed distance buffer. If people want to mess around with the segments thing, we can just run this like 2 or 3 times. If you want to try a different count of segments, does it have it in there? Okay, buffer distance, put in 30,000. I should have changed that in my slide here. Everybody's got that? I mean, if you got, you can just go ahead and click OK if you got that.
Should I browse for the shape?
Yeah, name it, give it a name where it's going in the end. And if you want to, for those of you who've done it already, you can run it again and put in a different value for segments and see what happens.
So here,
Yeah, you'll
suppose
hit
we-
browse,
browse.
and then this is going to be, so you have to specify how you're going to save it. Yeah, here, output shapefile.
Yeah, I've already,
Oh, is there? Okay, you're doing it again? Okay, cool.
yeah.
That's it. Yeah, no, it's good. This is where we're going to put everything. It's normal that you'll have like one folder that's all of your layers, everything all together. So hit save, and this one's, go ahead and click it. Yeah, you're good, so you can hit OK. Now you see here, it made a different, so here, oh yeah, this is another really funny thing with Q. So when you did your buffer, you clicked OK, and the window stayed there, right? If you click OK again, it does it again, and
Like, so
again,
you have
again,
two
again,
buffers?
again. So like you will have to click close to make that window disappear. And this will be like less evident on other tools, and you'll be like, okay, well I'm done, click OK, and then it runs the whole thing again. Whereas Arc will just be like, oh, we're done, you don't need this anymore, I will close the window for you.
Yeah, great.
So,
Doesn't to specify again.
yeah, so here, let's go. So, another little nifty tool that comes up a lot in here. So you made your buffer. And I see some people have 2 different size buffers on their screens. No problem, totally fine. Now we want to see which one's actually 30,000. There's this tool up here, this little ruler. If you click on that tool, and then you click in the center of the circle where your dot is, and then you drag it out to the side. It's going to measure that for you in the units of the map. Seems trivial, but when you're trying to understand your results later on and like verify if things are going properly or not, it's very.
You have to select one of the.
Okay, so everybody should have something like this. It's kind of a step, little check-in. For those of you with multiple circles, with multiple buffers, you can just uncheck the one that's not 30,000 meters. Oh wow, the resizing is really skewing things up there. We're good. Also, something you see the little boxes there. If you check in there, you'll see you can like click it. You can like hide layers. So it's there, but you can choose what you want to see or not. Ooh.
I don't have that.
If you grab your buffer layer, grab it and bring it down, and drop it.
Oh, okay.
So for people who are kind of new to this, these are the two objects we created. You can grab those and drag them around and choose what's visible. You can check them off to see them or not see them. All right, this is where things are going to get crazy. Okay, so we had no shapefiles at the beginning. We defined a point. We used that point to generate a larger region, which this is just kind of like a really sort of hacky way of defining a study region. So we could have drawn a rectangle. It would have been more complicated. But basically, this buffer zone here is what we want to capture all the data for all the rest of what we're doing. So I included that in there as like we're going from literally nothing up to a map in the end. So the OpenStreetMap project that I was talking about, we can fetch the data online, and it used to be a separate plugin that you would download it, install, and it gets used so often that they just built it straight into the software. And this is kind of we're going to download data from an online repository. We're going to pack it into a database, and then we're going to read that database to interpret the geometry, which forget about shapefiles. We are like beyond shapefiles now. Shapefiles.shp are actually proprietary to Esri, but because they wrote the book on GIS, everybody else is forced to use them. It's like .doc. Apple would really prefer not to use .doc because it belongs to Microsoft, but they have no choice because Word was fully established forever. This is what shapefiles are right now, but maybe in your later courses you'll learn shapefiles are really not the most efficient way of handling geospatial data. And what we're going to go and do now is more similar to the common everyday way of doing it. So even if all these steps aren't clear, doesn't matter. You don't need to worry about it. We're just going to follow a series of clicks, and we're going to wind up with some street network data in there. So step number 1, click on Vector, OpenStreetMap, and we're going to go download data. Now here, what's the extent of the data that we want to download? OpenStreetMap has data for every single city that anybody bothered putting data in. So like you could download the whole entire world and like maybe your computer will crash, maybe like it won't be able to handle it, you know? So we're going to specify the extent of our download from the layer, from the buffer. And when you click that, you're going to see the coordinates of your bounding box change. Who's familiar with the concept of bounding box, or who has no idea?
No idea.
So the buffer that we generated, it's a circle, but actually its bounding box is like the coordinate of the line at the top of the circle, the coordinate at the line on the bottom, and so like almost every single feature you dump in there, it has a bounding box, which kind of tells the computer, if I'm going to do an analysis on this buffer, to see what's close to it or what's overlapping. Does it need to scan 100 kilometers away from the buffer? Does it need to scan? No. I'm going to tell the computer, this is the box. This is what you need to worry about for this item. Don't waste your time calculating all that other stuff. There's nothing there. This is your bounding box. So Anyways, that's a whole tangent. Name this file and just call it, I think it's going to give you a default value. You can probably just accept the default value, put it into your project folder. So if you did this and you specified a saved file inside your folder, just click OK. And it's probably you're gonna see it download some stuff.
So like when you're talking about the bounding box, is a circle kind of, since it's a buffer, it becomes a circle, or does it take the whole box?
It's a rectangle around that circle.
Okay.
Yeah. If you succeeded in downloading a file, now go back into Vector, OpenStreetMap, and now do import topology. There you go. It's an XML file.
It's sound anyway. It's like, where are you getting that from?
You have to save it to the same place.
I think we saw.
Yeah, put it into the same folder. Everything we're going to save today is going back in the same folder.
Yeah, she working.
Okay, so now the step 2 is to import topology from XML.
So you're like, I don't know what I've done.
Well, because like if anything popped up, all it would say is download successful. That's it. Like
Yeah.
right now, there's nothing to display. If you went to that folder, you'll see the file there, but we don't have any spatial data to display right now.
Where did we
But it
download
actually
it?
shows you when it's
Because-
downloading. Like,
Because first we downloaded a package of data. Now we're going to import the topology, and topology is the relationship of points and lines in a graph. And now I'm really going to go off on a tangent here, but okay. So geography, things are in coordinates. I know I have one point here, there's another point there, I can measure meters between it. It's all happening in a plane that's full of coordinates.
Right.
Topology, you get rid of the plane. And all I have is that point 1 is connected to point 2 via a line that's this length.
Right.
Point 6, maybe it doesn't connect to point 1. There's no line that
Right.
specifies 1 connects to 6. If you ever did the cost path analysis, that's a topographical analysis.
Right.
So first now do this. Everybody has to go and do this. And then once that's done, nothing's going to display. Nothing's going to happen again.
Okay.
You're just like, what the hell's going on? Third, export topology to spatialites. Now, spatialite's the database management software that's gonna like display the shapefiles for us.
oh, download has been successful. Cool.
Yeah.
So then we close it.
Oh,
Yeah.
download.
Click close.
And it does it again though. So
Yeah, no, if you keep on clicking OK, it's going to do it over and over and over again. No, see, but right now it's trying to overwrite that other file, so let it keep going.
So for the spatial light, do we change anything in the menu, or?
Yeah, so, okay, I have to go to the next slide. So here's step 3, export OpenStreetMap to Spatialite. We're going to specify that we're creating polylines. Yeah, and that's, yeah, hit that. Those are, and this helps if you like, if you kind of drag the screen and make it longer, just so you can see that whole list. You'll see, like, look at how many things are in there.
So you're still using, never mind. Got it.
Yeah, so I would choose like highway, name, surface, and lanes.
Surface lanes. Okay.
And so scroll through that list and look at how big it is.
Yeah, no. Like you have railways and land farms.
And this is, remember I was saying like OpenStreetMap, it's open source.
Yeah.
So like, let's say you had a research project here and you needed street data and you needed, say, does this street have a school on it, yes or no? So your whole network is going to be flagged yes or no on every single street. Now you're going online, you can't find this data. Nobody's had to do this comparison before. There's no shape file that has a column, school on street, yes or no. You decide to go out there. You start cataloging. This street has it, yes. This street has it, yes. You come back to your computer, you open up your street file, you create a field, you start tagging yes, no, blah, blah, blah. You collect it for the whole island of Montreal. Now, because you're a generous researcher and you're nice and you want to help other people, you go and you add that data to the OpenStreetMap project, because maybe somebody down the line is going to need that also. And you just, so every single column you see in there, all of those options, these are the attributes that are going to show up in the table. And these have been put here by researchers, by whoever needed to use this product. So, so OpenStreetMap can be very useful in that sense. But so right now we're looking at Montreal, and we see this list of columns. Say we downloaded it for Toronto. There is zero guarantee the columns will match up. In fact, I would say it's a guarantee that they are not going to line up. So some research, if you're doing a comparison from city to city to city to city, you cannot use OpenStreetMap, because what you're looking for in one column might not exist in the other ones. And also, like, say the example of you're coding the schools, yes or no. Do you do it for the whole entire street, or is it for street segments? If you take a street like Gouin, that's like super, super long, there's probably huge stretches that don't have schools on it. So for you, for your research, what's important? Maybe somebody who coded it in the other city did it a different way, and they're no longer comparable. You're not going to be able to run stats on that. You can't use it. So, there's ways, you know, it's an excellent source of information, but you also have to be really careful about how you apply it. So did everybody do this? What you have to, we're making polylines. Click load from DB. This will be all of the attribute options that you can have in this file.
Yeah. I'm gonna go, sorry. But
okay.
I just want
And so tick off highway, name, surface, and lanes. If you do select all, you wind up with this gigantic file that's mostly full of garbage. Like there's going to be tons of empty fields all over the place, and like duplicated fields that have conflicting info when you don't know which one's good, and like, and then so like load the canvas onto the map when you're finished and hit OK.
the slides will be able to access to that?
Eventually, yeah, and there's going to be a video too of all the rest of it on GUSS's website.
GUSS.
Yeah. Yeah.
Is anything supposed to load? Darn it.
Oh, okay.
And you did load to canvas into map?
Yeah.
You just got like the buggy computer.
I got the buggy computer.
Oh, polylines.
But that's the .db already.
Did you do step 2? Did you do close this? Close that? Did you do vector, OpenStreetMap? Did you do this one? I mean, you can just grab a few, whatever. It doesn't have to be the same things. Doesn't have to be.
The dudes. Everything's a dude. Okay, highway.
Am I saying dude or?
I'm saying it's me.
Oh, okay.
I'm like not able to.
I actually have to be conscious of
Not
Oh.
highway.
surface.
Load. Send this one finished.
How are you doing? Are you yeah. Oh, sweet. You're good. You're good.
One thing. It's possible to have conflict information.
Yeah.
There's
And
something
even-
mechanism.
And even you see this. This is always the outline of a building. Actually, yeah. And that's the other thing about the OpenStreetMap data. It's not just streets. They have pathways. They have the outlines of buildings. They have like it's.
Yeah, I didn't know what the airport that
Yeah.
streets of the highway and stuff.
Yeah, look, it's actually the runway.
Yeah.
They actually have like the runways in there.
It's not working for me, but
So like the actual polylines layer for me shows up, but doesn't show it.
I don't even get this showing up.
Because the other thing
The
was,
extent, it was still the wrong coordinates, right?
yeah, I manually put the extent in.
Oh, here we go.
Look, it's still doing this. There's still something flipping. There's still something flipping.
I'm just wondering when the best way to know that.
Mine are different places though.
Whoa, you are not in Montreal.
I'm not in jail.
No, you're not in
Where am
Montreal.
I?
You are somewhere.
And like, if you put the Latin long in reverse, you'll get something really weird. You'll get something like, it's like down in Africa somewhere.
Oh, I can read to this entire thing.
Where's the layer properties again?
If you right click on the layer, yeah, maybe you do because there's something about how that was still on like, and if, see look, and like I didn't do anything, right?
Yeah,
I
it's
just
just
turned it
putting it
back
back
on.
on.
Yeah. Which is like seriously, I wrestled with that for so long. You don't understand.
I'll do this.
But it's okay. If we can keep going. In fact, on the next step, we're gonna get a good photo of where you are. It's gonna be interesting.
Where?
I think you might be somewhere in Africa. Because if you invert the latitude and longitude coordinates, you end up like down in Africa.
Interesting. I went to Africa.
Or no, where is it? It's like 45 over and 70 down.
Yeah.
So it's like you're in like South America somewhere.
I was 70 east and west though, and I was 40 north and south. Like 45 minutes south, 70 east.
Did you
west.
put in like N and S?
Yeah.
That's not what you're supposed to do.
No, not in an S, but like in the toggle box. Not the toggle box, like the whatever box. It was like 45 for the top, 45 for the bottom, negative 73, negative 73 for east and
Huh.
west. I don't know. I do it weird.
Okay, we're just gonna plow forward as if you guys have working maps.
That's fine.
So to select by attribute, select by attribute and select by location are things that you need to use like over and over and over in ARC. So in ARC, how do you view your attribute table in ARC?
Open.
Open attribute, right click.
Right click, open attribute table. So it's the exact same thing.
Yeah.
Thank you.
Can we do the same thing in ARC where you like nest it?
There is a way to do that. There is a way to do it. You have to, it's in the settings, and then you need to restart your session.
Oh.
And it actually, it doesn't, once you have like more than 2 tables, it does a horrible job of fitting them all in to the point where like data comes out and overlaps the other one, and it gets really messy, and like so.
Okay.
So sometimes I do it, and sometimes I don't. All right. Select by attribute is another thing that scares people in Q because it's so different. I need some data. In the top of your attribute table, there's select by expression. Yeah. It's this button, exactly. This
I'm
button.
not there yet. Yeah. It's just giving me menu.
And it's not, and this is another way where it's like it's not quite as user friendly as ARC, but it's more flexible. You have more control over it, but you need to know what you're doing with it. Okay, so right click on this file, and then open attribute table.
Attribute table.
And so all of these IDs, these are individual lines in the map.
Oh, yeah.
And then it's like, you know, what are they? What kind of surface is it? How many
Number of
lanes
lanes that they have,
has?
yeah.
Now, so here, this button up here, select by expression. Yeah, click that. And this is where, if I was your TA, I kept on driving home how SQL was select record from the layer where this equals that and blah, 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 blah. Now you're typing that out.
Oh.
You're typing that out yourself. Well, not so much you're typing it out yourself, but you're constructing it yourself out of what they give you there. And that's where like Arc is more like they hold your hand through it and they give you very limited options. Here you can type in a million wrong things and it won't tell you. It won't tell you. The main things are, I don't know why I don't have a better slide of this one, but in that middle section of that window, here we go. Yeah, this is what I was looking for. This is the key. This thing here unlocks all of the tools in here. So if you open up fields and values, there are your attributes. So just double click lanes. Now you have your math operators on the top, and there's also, if you scroll down in that middle section, there's another thing called operators. And
it's the same sort of like SQL Boolean.
Absolutely. So I'm going to go like lanes equal, or I mean, you can type it in, greater than or equal to 2. And like watch it, like if I put like lanes greater than equal to, and I put nothing, look, it says the expression is invalid. So Arc had like a verify button. This one, it just kind of tells you something's wrong, but it won't tell you what's wrong. And that's another way where like you need to have, you know, you're in control here. So in this, in all the options here, like look, there's this geometry section. So you could do like select to me, like say if it was a polygon layer, you could put like where area equals a certain value. And instead of going and creating an area column and populating it and then querying it, you tell it in the query, only show me the ones where area equals this. And you're saving yourself a lot of steps. So like for my work, the SQL stuff I write, I can have like an SQL query that's like 20 lines long. And I even have like, I use SQL to create loops where I'll be like, look at the first geometry, check all these conditions, how it relates to the other ones, record me the result, look at the next item, go do all of it. So that's like, GIS gets really powerful when you get good at SQL. So, okay, so if you go and you do that, it's going to select some, just click select. And then close, and it's going to highlight the roads with 2 or more lanes. I'm totally going off the rails here because it's such a small group. I'm going to show it, like I'm just going to show you general stuff. There's one of my favorite things of Q, and this is like the first thing I do as soon as I open up a new project. Go to project properties, general, and look at this background color. Whoa. And like depending on the data you're handling, this is just so much easier on the eyes. It's so much like softer on the eyes, or just like it's, especially if you're staring at a computer screen for like 10 hours a day. These little tiny tweaks here can like
apply to change the color, right?
Yeah. They're like look at this now. Look at how much easier this is to read.
Oh my word.
And like Arc probably has some equivalent. I have no clue where that is in Arc. I've never managed to do that.
It doesn't change.
Did you choose background color? Because there's another option in there. There's select color.
Yeah.
Okay. Okay, so now we still have your roads are highlighted, they're selected, right?
Yeah.
Okay, now how do we export that selection? How would you do it in Arc normally? You do like right-click data, export data.
Yeah, export
So
data.
now you just do right-click, save as. And so here you're going to choose the name, where you're going to put it. And save only selected features.
How do I make it so that I'm not measuring distance every time I click now?
You can just click like another tool. So basically you're downloading data maybe where there is none, because maybe you're telling it to go up north in Quebec and maybe there's nothing there. Here, these are the values. And also, if you're manually entering the bounding box.
This time I did not.
Okay.
I switched computers.
Because you know, like it would. Yeah.
Something.
Because like these coordinates, that's the center of that circle. So your bounding box would actually have to be 30 kilometers above it, 30 kilometers below, which like calculating decimal degrees, I would not even want to attempt. And this is why we do it in the UTM. Okay, so yeah, we're onto something new now anyway, so it's all good. Okay, so everybody has something that kind of looks like this, but you have your 2 layers of roads, right? You have the one with the 2 lanes or more?
Yeah.
Okay. So now, we're going to install a plugin. So in the top menu, if you grab plugins, manage and install plugins. Are these, when I do these screenshots and stuff, is this like too cluttered? Like, is it clear that I'm saying like go for this and this?
Yeah.
Yeah.
Yeah?
We also give you the option of Python console.
Hmm?
They also give you the option of the Python console.
Yeah. So,
Uninstall. Apparently it's already installed.
cool. Everybody search open layers and see if it's installed already or what might be the case. Which is actually like good because I was worried to see what would happen if we all tried to download it at the same time.
Is there like in the Arc toolbox you can always have like a search? Is there a similar sort of
Shared
thing?
coordinate system.
Open layer, one word.
Okay.
All one word. Not that I found, or really Google is my search box.
Okay.
Yeah. Stop.
Yeah. Everybody's got, so is it, if it's already installed, you can go straight over to this step here, step 2. Click on web. That's where you're going to find the open layers plugin. This is it's another kind of confusing thing about Q is that like you'll download that plugin and you have no clue where it went. It's somewhere in the menus. Maybe like, is it a research tool? Is it an overlay? Like it doesn't. So you install it and then you're like, okay, now, and then you have to like go and dig through all the menus to like find out where it is. Yeah.
They won't necessarily always open in web. They'll open like wherever they're.
Yeah. Some of them will go into the plugins menu. Some of them, if it's a vector tool, will go into the vector thing. Like it's, so like eventually there'll be some sort of like you'll discover some sort of logic to it, but it's not overly intuitive.
From Google Maps, is it physical streets?
Choose to your heart's desire. Choose a base map.
Satellite.
You can give Bing Maps some
Take
love.
the Apple Maps one. It's all images. It makes it look real old timey.
Whoa.
I don't know where I am.
The Apple Maps
You
one.
can zoom way out
Makes
now.
it look cartoony.
Oh yeah.
I'm in somewhere.
Ah.
I'm in Quebec.
Here.
Oh, did he copy his 47 from you?
No.
'cause
I
I'm
guess
pretty sure I wrote it down.
if it's 47, then this makes sense. How do you get out of?
I want to see something. Yeah, I've never done this stuff. So like, down to the spawn.
Wait. Marshall, how do you get out of the ruler?
Just choose another tool. Click like the hand is pretty. The hand's pretty harmless there. So now, like, zoom way out. Zoom way out and see what you've got.
And just like that cluster of data.
Whoa.
It's the whole entire planet.
And you were
Oh
right. I
shit!
did
Oh my god! Look
47.
at the ice sheet. It's like so small.
So
Shit.
just to illustrate, like at the very beginning, we set the extent of our map. It was the UTM zone 18. That should have been all of the workable space. Now we use this plugin. It loads an image of the whole entire planet. So, okay, the two main data types in GIS, there's vector data and there's raster data, right? And in Arc, you can also slap images in there, right? Because an image file is encoded just like a raster file, right? Like every cell has a color value, and that's what creates the picture. So we're totally bending the abilities of raster to display these photos. That's what's going on here. It's sort of like a raster layer, but not exactly a raster layer. So I was gonna go through how to clip this layer to our study zone. We can definitely do it, but it's not clear. It's not obvious. It takes a little bit of time. Okay, go back into that tool and get the OpenStreetMap. In the Open Layers plugin, go back in and choose OpenStreetMap. And if you have a Google layer or whatever, just delete it. Like right-click, remove. And if you want, you can like hide your uncheck your buffer. So we just have the roads and the OpenStreet map base map. So before, with the OpenStreetMaps plugin, we downloaded the street network and we said what attributes we wanted. And now we just went into a different plugin and said, get me into base map from OpenStreetMap. So like, what's the difference between those two things? Well, why do they look so different?
Between the two maps?
On,
Between the OpenStreetMap and the silent?
on the image, on the OpenStreetMap base map that we just downloaded, try to select for me the roads where there's 2 or more lanes.
Changes the colors.
So you remember how we select by attribute? So go to the image layer.
It doesn't have an attribute table.
Exactly. So like, I'm asking you trick questions to like lead you down a path here.
So is it just an image?
It's just an image.
Ah.
There's no data to query there. The image doesn't know that this is a highway and that's a road and that's a park and whatever. All it sees is pixels and color values. That's it.
Oh, I see.
No.
So the reason I took us down that path is just to really sort of reinforce for you guys the difference between the vector data and the raster data, and like what's possible with each. And here we have 2 very different representations from the same source. So the open layers plugin and this base map, it's for making your maps look pretty. This is about it. And if you're working in a company and your results are presented in a map and you need to hand them over to your boss, or you're pitching something, or you're trying to get funding with a presentation or something, things being pretty really count for a lot. If you handed over just that street network with the things highlighted, they might not really understand what it is. And then as soon as you have like, oh, that's the airport, oh, that's Mount Royal, they know where they are, it instantly makes more sense to the reader. So that's like, yeah, that's kind of like the main reason this plugin exists. There's also a whole other way where we can open up Google Earth, find a location, take a screenshot, and then you'll find like, say, like a big red house, and you'll get the coordinates of its bottom left corner, and then you load the image into Q, and then you go in and you say, this bottom corner right here, these are the coordinates of this one. And then you need at least 2 more to define a plane, and then you can steal images from Google and geo-reference them, and then use them in your maps and stuff like that.
But can you just do that through the plugin?
Now, so the next step we're going to do is because again, this map is like the whole entire planet, but we don't need that. So we're going to chop it down just to our study zone. With the OpenStreetMap, we can do that. With Google's, we can't. Google, you get the whole entire world, and that's it. And this is why I'm saying we need to steal it from Google Earth, is because Google doesn't want anybody using their images. You're not allowed to share. You're not allowed to, no. So like, you're like, oh, I want to clip this to my city, and they're like, no, you're not manipulating our data. Once you clip that, you have your own layer that you can go off and do whatever you want, but they actually spent tons of money to build it. So Google, Bing, and a couple of the other ones there, they're really stingy with their information. So that's also another reason why I steered us towards the OpenStreetMap one, is that this one we're actually going to be able to chop it and manipulate it as if it was just a regular raster layer. Before we clip it, all right, let's go down this road here. So now we have this map. We want to chop it to fit our buffer circle. Before we can do that, we need to convert it to an image. So if you right-click on it and go Save As, and like, look, Save Raster Layer As, it interprets it as a raster. You're on the wrong layer. OpenStreetMap, the image of the base map. Save as. We're going to do rendered image. Output mode rendered image. If we choose raw data, we'll be here for 15 minutes waiting for it to process. So rendered image, point it back to your project folder, save it in your project folder, call it open chopped or whatever, open image. Oh, sorry. I skipped a step. Close this window. And right-click on your buffer layer and go zoom to layer. And your map should just like recenter and like resize. And now go back into your right-click Save As. And why I told you to center it will become apparent in a second. So if you right-click on that buffer layer, no, buffer. Yeah. And then, no, here, right-click. And then do zoom to layer. And there. And so it fit inside your screen. So just leave that. And now we're going to go to the OpenStreetMap. And is it still that issue? Okay, no, okay, cool. So right-click on your OpenStreetMap image.
Save as.
Save as.
Rendered.
Rendered image. Give it a name. And then here, what's the extent? And like, if you do layer extent, you'll notice that the coordinates go all the way around the world.
Oh, shit.
But we're actually going to go map view extent, which is why I made you center the map on the buffer.
Okay. I think mine might take a while.
And so did you set this? Okay. Yeah, it does take a little. It should only be like a couple minutes, so.
Okay. I'm at 2%.
Mine just crashed, I think.
Processing power.
No, nothing else.
Oh no. She gone.
And for this one, we leave the CRS as what it wants, because apparently changing it just like throws a wrench in the whole thing for this one, because all we're doing is getting the image right now. Yeah, see, I was worried about this for this one. If it's taking a really long time, you can cancel it, and then your resolution, you can change it to like 30 by 30 or like 100 by 100, and then it's just your image quality that drops.
Yeah. Well, there's only one more step, right?
Yeah, I guess so.
Okay.
Yeah, I mean, like, I'm just going and going. We can end this at,
Just have it at 2, maybe?
sure. Yeah, this is where like I've got a beefy laptop, and it took like a couple minutes to do that,
Great.
and I was like, I really hope that the computers here are stronger than my laptop. Like,
I
they
don't know.
they should
I'm
be.
gonna do this all at home. Where
You say that?
I can.
Sorry, I'll go back to.
So you said to put the resolution to what?
Try like 30 by 30. I was gonna say 10 by 10, but it will just go faster if we process bigger chunks.
No, this is fun. Tinker. You get to tinker with it.
And then we save it, right?
Yeah, you'll have to.
Oh, I did it again.
Like a text box?
Okay, so yours finished going? Okay. So now the whole point of that was to create something that we can put into a clip tool. Because that original weird kind of a raster, not a raster, whatever, you couldn't do any tools on it because it's some weird format that they're cheating to get images in there. I'm sure there's an actual better technical explanation for that, but so now so it's an image file, it's pixel by pixel, therefore it's a raster data type. And we're going to go raster, extraction, clipper. You put in the file that we just made, give it a save name, you know, like image clipped or image masked or whatever. The clipping mode, we're gonna use buffer as a mask layer. And if you remember, like in raster, mask is like a fancy word for overlay.
Sweet.
All right. So now we should all be something like this. I also wanted us to clip the road layer, and you know how to do this already. It's just like that's where the button. It's a vector, you know, like that's a vector process. So it's underneath vector, geoprocessing tools clip. Which is input, which is clip. I've Googled this in my life like a million times. I've never, and it's only like once like clip layer. That's the cookie cutter. That's the shape you want to chop, and that's how I remember this.
So
I mean,
it's
clip is like
MTL buffer.
it's pardon me?
MTL buffer.
Yeah.
Okay.
That's the cookie cutter.
And the input is as if you were doing it on the actual layer itself.
The input is what you want to chop.
Okay.
You have a machine called Clipper. It's got a cookie cutter in it. You put in a layer, it cookie cuts it. You keep what it takes. So, yeah. So like I'm not. I mean, if you want to run through it right now in 2 seconds, go ahead. I think that was. So you'll wind up with something more or less like this. seriously, I spent like 2 hours Googling that yesterday, and which like I do not even believe. And every single thing I saw written about it was talking about this is how you do it in Python. At the beginning of your Python project, this is how you set the extent, and it stays in there, and everything else goes to that. I know when you're playing with raster data, there should be convenient ways of masking your other layers to a shape. I haven't worked too much with raster in here, and hopefully it's in there. But seriously, so this whole like convert it to an image file and blah 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 blah, that's the workaround for getting this image to fit inside the extent of your project. There was no, because I know, what is it, in Arc you can do like geoprocessing environments and you can set a fixed extent for it. I could not find anything like that in like the UI.
And you could even just like clip it to a
like a particular layer.
Yeah. But it keeps all the data around. It's just not visually there.
Seriously, I couldn't find it, and it really, I was really surprised. So I kept on sort of digging, and everything I found was bits of Python code of like how to do that at the beginning of your project. And oh, print composer. So you're gonna go project. So project new print composer. Name it anything you want. It doesn't matter. Mash the keyboard. We're never coming back to this. Okay, if your clip feature is not in the same projection as your buffer, you are basically dropping your cookie cutter down where there's nothing, and then it's saying here's your nothing in a new file you just named.
Okay, so my initial mistake.
I made a poster I want to hang up in here. It's the gonna have a bad time meme.
Yeah.
And it's like if all your layers aren't in the same projection, you're gonna have a bad time.
I think you should.
So I was gonna like hang it up by the door there or something. We should just fill the room with reminder memes. Okay, everybody. So you have a print composer open. So this right here. Okay, I'm gonna give you like the thing that messes everybody up and is not obvious at all. And so here, this button right here, add new map. So first of all, this sheet of paper, this is your piece of paper. This is the actual piece of paper that you're going to print out. It's like print view when you can see the border of your paper. Now when I click this button, add a new map, I'm going to trace out a box, and the box is exactly where I want my map to land on the sheet of paper. So like if you want to leave room for a title, leave a blank space for a title. And like, look, I'm going to do this. And as soon as I release, okay. So, this is where things get confusing, is that like what it decided, okay, I drew this rectangle and it filled it with my map, but like where, zoomed where, how did it decide, why did it put all this empty space here, what's going on, why did it do that? The reason it did that is that it paints exactly what is in your view screen here right now. So now when I go like, I can like zoom in here. And now when I draw a new box here, I'm gonna erase this box. Now when I draw a new one, so like here, like let's say, so I have my map, it's all Montreal or whatever. Here, like I can do, that. This is also something that works in Arc. It's like you can choose your magnifying glass and like draw a rectangle to zoom in. So like, okay, I want, what is this? The 15 leading up to the Champlain Bridge. Oops. So there, I zoomed in. This is what I want. Now in my print composer, I can delete this map here. And then I go new map. I draw where I want it to go. And it fills in exactly what's showing in my data view. Now, okay, so I dropped that in there. Now, wait, now I want to go, I'm going to look at where the bridge connects to Nuns Island. And now I can come over here and go, you know what, draw me a different map. Back over here. Okay, and actually I want one that's Laval because the topic of my map is bridges. I don't know. Draw a map. Drop that in there. So imagine how long that would have taken in ARC. You would have needed 3 different data frames. And like all I did was go and pan around and zoom around, and it did this. And now, so look, now here's all the rest of your tools. Like here, I'm going to draw a scale bar. So there, all I did was click this button here, add scale bar. And then I drew where it's going to go. Now, in ARC, when you add a scale bar, you're used to this pop-up screen with all the options right there, and you choose which one you want to put in there, right? Here, it's a bit different. Here now, there's item properties. So like right now, my scale bar is highlighted. That's the item I'm playing with. And we go to item properties. Okay, scale bar units, meters, unit multiplier, how many segments. Look at all these different options. Should the box have an outline, fonts and colors. So you have to like create the scale bar item and then go in and start messing around with it. It's not going to give you options from the start. So everybody saw like the scale bar options, and now the same deal. Like, what is it? This one. Yeah, it's how you draw it, and I'm trying to remember. There's a really weird way of getting an accurate north arrow in here. So there I did add legend, and my item properties window automatically changed to the options for the legend. And here, like, this is where you would like rename the items. Yeah, there. So, yeah. So that the print composer was the last thing I wanted to do. The north arrow, I think I Google this every time I need to do it, but it's like you need to add an image. The north arrow is actually an image, and then there's a way that you connect it to the grid lines in it, and so it will like orient it automatically to be north. I didn't take a lot of time going through finding cool plugins. One that I found, like this clip multiple layers. It takes, when you open clip multiple layers, it just asks you for your cookie cutter shape. And then whatever's visible in your map, it just does all of them. And like, it's kind of slow, but I mean, like once you hit go, you need to like sit back and just let it go and go and go. But it's just easier than like reopening the tool 6 times over to do it. And also like, so I had these raster layers in there. I had the image layers, all this stuff. When you pull up that tool and you hit go, it just does what it can and ignores the rest. DEM to 3D. This is like, it takes digital elevation models and turns them into a file format for 3D printers to print it out. Yeah, which I thought is like really cool. Like that's, so, you know, how many people in the department are going to use it? You know, this guy. But that's where like ARC would never waste their time making that tool. And the guy, whoever coded that, is totally like an art project. It's totally like just for fun. Or like say if you're presenting scale models for your urban planning stuff or whatever, and you want the ground to be a nice, you can print this completely accurate now. So like, so somebody needed that, they programmed it all themselves, and all it is, it just converts it into a different file format so that your printer can read it, you know? So there's all sorts of cool stuff in there that ARC would never bother going near, you know? Like the Street View one, I think this is like, what is it? I think it's like, I don't know if that's like Italian or like, but is that Italian or, I don't think it's not Spanish.
Yeah,
Is it Italian? So, from my understanding, it fetches Street View images of buildings. So like with the plugin running, you can click on addresses like buildings, and it will load a street view preview for you. So like, imagine yourself if you had to like present a plan of a city block and like have it interactive like that. Now we have like these fancy interactive PDFs and stuff. Like imagine how much work would be involved in that. And this guy, here's a plugin, and you can go and you can do it. And you just got to dig through that menu. There's all sorts of cool stuff in there. There's really weird. There's things published there that like, why is this even public? Like this one coder needed this one little task to convert this to that, and maybe it's not useful to anybody else, but it's in the repository. Maybe it's useful for you.
Someone might.
Yeah, like years from now. Yeah, and that's
Cool.
everything I have.
Thanks, Mark.
You're welcome.